Now, I mentioned that I've included a switch with at my core level. What I want to do is I want to stack it, and that brings in a new thing that we're going to talk about briefly, and this is how we're going to build the rest of our network. So what we've seen now is we've seen this very standard topology where everything's kind of connecting all at once, and we grow it in a sort of ad hoc way. So we plug in our device, we give that switch an IP address, and we run out of ports, and then we plug in another device, we give that another IP address, and before you know it, we've got these kind of mesh systems where we're trying to plug everything in, we're trying to give everything a device. Now, the problem with that is you want to make a change in your network. Where are you going to make the change? How are you going to make the change? And if it's something that has to go network wide, think about all the work that has to happen for that network for you to make that one simple change. That's not even accounting for if you've made the right change and then you have to start reverting things. It's all going to get very, very messy. So it's not really the system we want to use. Now, stacking is what we call it. Physical stacking is where you introduce fiber cables. We call them DAC cables, direct attach cables. They're very short cables. Now, in our instance, we use 10 gig cables. So what we want to do is we want to connect each switch with a 10 gig cable, and then on the final one, we loop that back to the first one. So here I've got a ring stack. Now, what you'll notice about this, Alan, right, is that you're able to take one of these switches out, and it won't affect any other switch. Okay, so if one of them breaks, if the PSU goes, if something goes wrong, if it gets zapped by lightning, whatever, starts malfunctioning, it won't affect the rest of your network in that way. We can rip it out. Now, what's also important is this stack has one IP address. It's manageable via that one IP for all of the ports that are on this device. So you don't need to worry about multiple IP addresses. It's all in one system, one block. Now, if you're a small company, if you're a small business, you might be able to put in a stack of switches like this. You'll have one IP address to manage for your entire network with redundancy. If anything goes down as well, you'll be able to chop and change ports, change all the VLANs, make everything segmented, and off you go. If you're a big company, you want multiple stacks. Yeah. So we've introduced the concept of device breaking down. Now, if we link these devices and these stacks together with a fiber cable, what we can do is we can start pushing information between the stacks. However, if one of those fiber cables goes down, we've lost communication going to that stack. So there's multiple things that we can do on our switches to try and alleviate that. One of the things we do is called LACP, or spanning tree protocol. And there's two ways of doing it. Now, if I introduce secondary cables, now anybody who's played with switches in the past and has tried to make a loop knows it throws a tantrum and it starts shutting down the rest of the network. However, if you apply a certain technology and you do it in the right way, what you're able to do is not break the network but improve it. Now, what we've done here is I've done two different cables, one going from the first switch, one going from the sixth switch in that first stack, go into our second stack. Let's say that's, for example, every one of those red cables is 10 gig. I've now got a 20 gig connection going from stack to stack. It's constantly up all the time. If one of them breaks, I still have a 10 gig stack that I can use. If one of those devices goes down, it doesn't break the rest of my stack because it can go another way. So, for example, if the third switch in the first stack breaks, I've still got all those ways of getting to that second stack, and all that technology doesn't kill the rest of my network. Yeah. And that's really what we probably do very well, I would say, at D-Link, is that we can start planning those kinds of networks. So